What you saw right there was a live replay of me getting cooked by Chess Engine. And no, it's not because I'm like 200 elo and this is my first game of chess ever. I actually grew up playing a little bit of chess, but the thing that's unique about this Chess Engine is it was coded entirely by an LLM. All I had to do was set up the right scaffolding, and with a little bit of research, I told Claude, maximize the elo of this engine and make no mistakes. So much hype with agentic AI. I was a software engineer. I watched my job get automated in real time 4K live. So I asked myself, can I get an AI coding agent to tune a chess engine for me? Just out of curiosity, because it's a game I played a lot when I was younger. So short answer, yeah, I was able to, but let's actually see how I did it. If you take a look at this chart, it started off as a complete beginner at roughly 800 elo, and by the end of the 24 hours, it rose to 2600 elo. For reference, the average chess rating is around 8 to 1200 elo. If you're curious, my personal best in Rapid is about 1400 elo, so still pretty trash, but at least a little better than the average person. So the engine we make shouldn't have too hard of a time trying to beat me. Now, a chess engine is simply a program that looks at the current board position and tells you the next best move. It does this by first searching through possible moves and then evaluating which positions look good. And this engine, it has hundreds of parameters, things like how much is a knight worth, which row should a rook occupy, or what is a good pawn structure. Traditionally, you would run the engine, see what it did poorly, then tweak the parameters by hand, then repeat. Now, there's a project called Auto Research from a gentleman named Andrei Karpathy, who's kind of the GOAT in the scene. But basically, Auto Research did everything I just said autonomously. It changes parameters, runs games against Stockfish, estimates the elo, makes the adjustments, and then just repeats the whole thing. So instead of reinforcement learning, the learning comes from an LLM reading code, forming a hypothesis on what could improve performance, editing the source code, then testing empirically. And if we let this run for long enough, the hope is we come out with a nicely tuned chess engine that can become an international master. But how does this actually piece together and work? The core of the chess engine is using something called alpha beta search, which is the same algorithm that powered Deep Blue to beat chess legend Garry Kasparov. Let's just consider the following. You are in a given position and you have 30 possible moves. Then after your move, let's say your opponent has roughly 30 moves. And then at a depth of 8, meaning we're observing the state 8 turns away, the engine would need to see the roughly 30 to the 8 positions, which is 656 billion positions. Then it needs to evaluate them all and find the best move. That's way too many computations. From a high level, alpha beta search is just a smart way to search through possible moves without wasting time on obviously bad ones. I started this implementation in just pure Python. It kind of worked, going from 800 elo to 1300 elo, but because Python is not really the most efficient language, it could only reach a depth of 1 to 3, meaning it could only see 1 to 3 moves ahead. And if you play chess at depth 1, the engine is basically blind. It can't see a knight fork from 2 moves away. So the bot quickly hit the ceiling and I was still able to crush the bot. To get over this wall, I implemented the engine in Rust instead. This was a huge improvement, with the engine now going from a depth of 1 to 3 to a depth of 8 to 9. And I was able to get the baseline of the engine to 1600 elo, and then upwards to 1800 elo. As we ran auto research, we can see it implemented some smart techniques to improve performance, like all of this nerd stuff you see in the graph here. How does auto research actually work? It's very, very simple, and it essentially boils down to one file, the program.md file, or really just any MD file that has your set of instructions. It has all the instructions, like telling the agent, here's the source code for you to edit, here's how you build it, here's how you test it, and here's the thing you need to optimize for, which in our case is the elo. The agent will read the file, and enter a never-ending loop until you stop it or run out of tokens. That never-ending loop sure ran through my Claude Max plan, but it also developed an engine that destroyed me in the end and reached upwards of 2600 elo. So with that, enjoy the full game of me getting bodied by the bot.